Complementary or cofunction identity. We have 6 of them. So the first one is that sine theta must be equal to cos 90 minus theta. And you know 90 could be, we can write 90 as pi over 2, so anyone. Again, that cos theta is the same thing as sine 90 minus theta. Theta is cosec 90 minus theta. Also, that cosec theta is sec 90 minus theta. Again, that tan theta is cot 90 minus theta, and cot theta is tan 90 minus theta. So we have 6 of them. Looking at this, you notice something. Cosine means complement of sine, that is 90. Sine theta, cosine. Cos, sine. Okay, these ones are set to sec, cosec. Tan, cotan. So that's how you remember. So we have 6 of them. So assuming, let me give a quick proof to this. Assuming you are given this is a right angle triangle where this is theta. Assuming here is A and here is B. Let's call the hypotenuse C. You know this angle must be 90 minus theta. Yes. So you now see that sine theta, if you check, sine theta is opposite, which is, that's my angle is theta now, so A over C. Again, if I now take 90 minus theta as my angle, you notice that cos 90 minus theta will still give me A over C, because it's adjacent. If the angle is 90 minus theta, the adjacent, B is the opposite, while the adjacent is A. So I'm using, they have the same value. So again, if you try others, that's what you observe. So that's the identity. Example now, if you are given maybe sine 30 is the same thing as cos 90 minus 30. So which is cos 60. So sine 30 is equal to cos 60. Or maybe if you are given tan 70 is the same thing as cot 90 minus 70. So which is cot 20. So it's just simple, just subtract, check the one that relates. Tan, cotan, sec, cotec, cosec, cos, sine, cosine, sine. So they are related. Quadrants. So we have quadrants. We have 4 quadrants. So we move anti-clockwise. So we are moving in this direction. So remember, this is a circle. So each of the quadrant, the total angle is 90. So here, the angle, this is first quadrant. This is second quadrant. This is third quadrant. This is fourth quadrant. So in first quadrant, the angle here must be greater than, or that is must from 0 this must be from 0 to 90. So angle from 0 to 90 falls in first quadrant. So theta is between 0 and 90 inclusive. Why the second quadrant must be greater than, the angle must be greater than 90, that is 90, from 90 point something and 180. So it must be from 90 point something to 180. Why the third quadrant must from 180 point something to 270. Why the fourth quadrant must start from 270 point something to 360. So that's what we have in fourth quadrant. So but we need to, because the target is to learn how to convert. Second one, the actual angle is always 180 minus given angle. So any angle they are given that falls within the second quadrant, you subtract it from 180. That's what the angle that you use. Why in third quadrant, the actual angle you are going to use is now the given angle minus 180. So how do you differentiate? You know, inside second quadrant is between this, so you subtract from 180 is greater, but in third quadrant is greater than 180, so you subtract, you remove 180 from the given angle. So why the final quadrant, which is the fourth quadrant, the actual angle you are going to use is now 360 degrees minus the given angle. So let me just use a quick example. If someone asks you, okay, before then we need to add extra stuff. In second quadrant, only sine and its reciprocal are positive. So what is the reciprocal of sine? Cosec. So only the two are positive. Other trig functions are negative. Again, in third quadrant is only tan and its reciprocal, which is cot, are positive. So in third quadrant. Why in fourth quadrant only cos and its reciprocal, which is sec? In first quadrant, all are positive. All the trig functions are positive. So with this information, we can solve a lot of questions. Example, if you are asked to find sine 240, so what you have is 240 falls within which quadrant? Third quadrant. So the actual angle is now the given angle minus 1. So we need to do 240 minus 180. Again, is sine positive in third quadrant? No, it's only tan and its reciprocal. So it is now minus sine. So we are saying that sine 240 is the same thing as minus sine 240 minus 180. And 240 minus 180 is 60. So sine 240 is the same thing as minus sine 60. Again, if someone asks you to find cos 120. 120 is in second quadrant and is only sine and cosec are positive, so it is now minus cos. Again, 120 is within second quadrant, which means that 180 will subtract 120. So what we have here is minus cos 60. So that's the quadrant. So we're on special angles. We're going to use the knowledge of quadrants, complementary identity. For us to, let's get sine and cosine first. Sine 0 is always 0. Sine 30 is half. Sine 45 is root 2 over 2, or 1 over root 2. Sine 60 is root 3 over 2. Sine 90 is 1. So let's stop here. Remember, from sine theta is now cos 90 minus theta. That's complementary identity. So we are saying that sine 0 is now equal to cos 90. Why? Cos 0 is the same thing as sine 90. So this is 1. Why this is 0? Yes, the value of 0 here is the same thing as 19 here. So why 30 and 60 are also related. So meaning we switch value. This is now root 3. Why this is half. Here 45, they are the same. So 45 minus 90 minus 45 is the same as 45, so the same thing. So do you see how I fill in the other that's from 0 to 90? For remember, we are now in second quadrant, so sine 180 is the same thing as, remember, sine is positive, and 180 in second quadrant we subtract from 180, so 180 minus 180 is 0. So we are saying that sine 180 is the same thing as sine 0, which is 0. Y270 is in third quadrant, so we subtract 180. 270 minus 180 is 90. But in third quadrant, only time is positive, so sine is negative. So we have minus sine 90, and sine 90 is 1, so we have minus 1. Again, fourth quadrant, 360 minus, so 0 and this, you have the same value. So coming here again, cos 180 is the same thing as minus cos 0, because 180 minus 180 is 0, so we have minus 1. 270 is the same thing as 90, because 270 minus 180 is 90, and in third quadrant cos is negative, so minus, so 0, so no need of wasting time, 0 is minus. So why this 1 and 360, 0 and 360 will be the same, so 1 1. So since we've gotten the values of sine and cos using quotient identity, that tan is sine over cos, so we have 0 over 1 is 0, this over this is 1 over root 3. So this over this is 1. This over this is root 3. 1 over 0 is undefined. You cannot see. So it's infinity. 0 over minus 1 is 0. The same thing. Okay, negative infinity. So why 0 over 1 is 0? So we can solve any problem. Once you know this, once you remember sine from 0 to 90, you can still fill in others. So